Hi, thank you for being here today. This is Janet Stramel, and I'm at Fort Hays State University in Western Kansas, and this is Games to Promote Student Learning. I currently teach mathematics methods courses at Fort Hays State University. I've been here 7 years. I also am a National Board Certified teacher in early adolescence mathematics, and before I came to the university, I was a middle school mathematics teacher in both Oklahoma and Kansas. Thought I'd show you where Fort Hays State University is. We are in Hays, right here. Hays is about halfway between Kansas City and Denver on I-70. Okay, I'm going to go ahead and get started. First, I want to tell you about why play games in the mathematics classroom. It should not surprise any of you to know that one of the most consistent findings in educational research demonstrates that the more time students spend engaged during instruction, the more they learn. Some researchers even identify differing levels of engagement, and Schlechte defined 5 levels of student engagement. Authentic engagement, where students are immersed in work that has clear meaning and immediate value to them. A ritual compliance is the work has little or no immediate meaning to students, but there are extrinsic outcomes of value that keep them engaged. For example, you earn a grade, and so you're in that ritual compliance. Passive compliance, students see little or no meaning in the assigned work, but expend effort merely to avoid those negative consequences, such as not having to stay in during recess if they don't complete their work. Retreatism is when students are disengaged from assigned work and make no attempt to comply, but they are not disruptive to the learning of others. And then the rebellion is where students refuse to do the assigned task, they act disruptive, and they attempt to substitute alternative activities. So we want our students to be authentically engaged in our mathematics classrooms. Making learning fun motivates students and helps them pay attention and stay focused on the subject. One reason to promote educational games is to encourage students to learn outside of class. Young adults will go out of their way to play games, even a simple game, and they will play that for hours on end. There's also evidence that games allow students to focus well enough to learn better. And some researchers have found that rewriting a lesson with a story context combined with a challenge for the student to overcome significantly improves the learning performance. One reason that games are such a great escape from the real world is that bad consequences rarely have serious or lasting implications. We frequently say, it's only a game, or if you lose, start the game over and try again. Often it's possible to recover even within the game and to use what you've learned to successfully complete that next task. And the great Fred Rogers said, play gives children a chance to practice what they are learning. They have to play with what they know to be true in order to find out more, and then they can use what they learn in new forms of play. Since ancient times, manipulatives have been used to help solve problems. An abacus, tallies, stones, beads, wooden counting boards, money are just a few of the tools that people use to help them learn mathematics. A few of the activities or games you could use are to help kindergarten students learn about coins and their value. You could have your students use a magnifying glass to observe each coin, have them sort the coins into jars, toss coins to predict their landing. Students could also learn to count money by filling a plastic Easter egg with coins. For example, you could write on a strip of paper, blank nickels equals 25 cents. The students would then have to put the correct amount of nickels into the egg and write the answer on a piece of paper. Another activity is with yardsticks, where your students could go around the classroom and measure items. You could also have your students use beads, coins, and candy to help them solve math problems. Any manipulative that you think would help keep your students actively engaged would be considered a hands-on activity, and you could make a game of that. The National Council of Teachers of Mathematics and the National Association for the Education of Young Children published a joint position statement in 2002 and then updated it in 2010. They affirmed that high-quality, challenging, and accessible mathematics education for young children is a vital foundation for the future of mathematics learning. In every early childhood setting, children should experience effective research-based curriculum and teaching practices. Throughout the early years of life, children notice and explore mathematical dimensions of their world. They compare quantities, they find patterns, navigate in space, they grapple with real problems such as balancing a tall building block or sharing a bowl of crackers with a friend. Mathematics helps children make sense of their world outside of school and helps them construct a solid foundation for success in school. So the opportunity is clear. Millions of young children in either child care or early education settings where they can have significant early mathematical experiences. Accumulating research on children's capacities and learning in the first 6 years of life confirms that those early experiences have long-lasting outcomes. Developing computational fluency is an expectation in the Common Core standards for mathematics, and games provide that opportunity for meaningful practice. Again, the research about how students develop fact mastery indicates that drill techniques and time tests do not have the power that mathematical games and other experiences have. So people say games in math, how can that be math? But the NAEYC position is clear that early childhood programs should allow children to learn mathematics through play. And that should be tailored to the ages, interests, languages, and cultures of all children. You know, people of all ages love games, and they love to play games that are fun and motivating. Games give students opportunities to explore fundamental number concepts, such as counting sequences, one-to-one correspondence, and computational strategies. Engaging mathematical games can also encourage students to explore number combinations, place value, patterns, and other important mathematical concepts. They also afford opportunities for students to deepen their mathematical understanding and reasoning. Teachers should provide repeated opportunities for students to play games, then let the mathematical ideas emerge as your students notice new patterns, relationships, and strategies. Games are an important tool for learning in the early childhood and elementary school mathematics classrooms. Playing games encourages strategic mathematical thinking as students find different strategies for solving problems and deepen their understanding of numbers. When games are played repeatedly, they support students' development of computational fluency. Games present opportunities for practice, often without the need for teachers to provide the problems. Teachers can then observe or assess their students and work with individuals or small groups of students. Games have the potential to allow students to develop familiarity with number systems and benchmark numbers such as tens, hundreds, thousands, and engage in computational practice and build that deeper understanding of operations. When considering the use of games for teaching mathematics, Teachers should distinguish between an activity and a game, and I did give you some activities earlier. I'm going to give you some games in just a few minutes. A game needs to have 2 or more players who take turns, each competing to achieve a winning situation of some kind, each able to exercise some choice about how to move at any time through the playing. And the key idea is that it's a choice. In this sense, something like Chutes and Ladders is not really a game because winning relies totally on chance. Players make no decisions. They don't have to think any further than counting. And there's also no interaction between the players. Nothing that one player does affects other players' turn in any way. So mathematical games should involve a challenge, usually 1 or more opponents. They're governed by a set of rules, and there's a clear underlying structure. There's normally a distinct finishing point or an end to the game, and there should be a specific mathematical cognitive objective. A good way to introduce a game to your class is for the teacher to play the game against the class. After you briefly explain the rules, ask your students to make the class's next move. Teachers may want to also model their strategy by talking aloud for the students to hear your thinking. So you could say, I placed my marker on the 6 because that would give me the largest number or the greatest number. Games are fun and can create a context for developing students' mathematical reasoning. Through playing and analyzing games, students also develop their computational fluency by examining strategies that are more efficient and by discussing relationships among numbers. As teachers, we can create opportunities for our students to explore mathematical ideas by planning questions that prompt students to reflect about their reasoning and to make predictions. Remember to always vary or modify the game to meet the needs of your students. And encourage the use of the Common Core standards for mathematical practice. You should hold your students accountable no matter what age they are. While playing games, students should record their mathematical equations or representations of the mathematical task. This yields data for students and teachers to revisit, to examine their mathematical understanding. And after playing the game, have your students reflect on the game by asking them to discuss the questions orally or write about those in their mathematics notebook or journal. You could ask, what skill did you review or practice today? What strategies did you use while playing the game? If you were to play this game a second time, what different strategies would you use to be more successful? And another question you could ask is, how could you tweak or modify the game to make it more challenging? And students would come up with that. One of my favorite things is 10 frames. There are several games you can play with 10 frames and related to number relationships. This activity is at the NCTM website under the Illuminations, and it's in my references at the end also. 10 frames and dot cards can be used to develop student subitizing skills, the ability to instantly see how many. This skill plays a fundamental role in the development of students' understanding of number. There are 2 types of subitizing that exist: the perceptual subitizing, that's closest to the original definition of subitizing, recognizing a number without using other mathematical processes. For example, as a child might just see 3 and know it's 3 without any learned mathematical knowledge. And then conceptual subitizing is being used when a person sees like an 8-dot domino and just knows the total number. The number pattern is recognized as a composite of numbers or composite of parts and a whole. The domino is being composed as 2 groups of 4 or as 1/8. So one of my favorite games is Flash. You could use the 10 frames, or you could just put dots on a paper plate or a whiteboard and have the students say the number. The response is oral, so this really isn't a game like in the sense that I was explaining games a while ago, but it's a good activity to get to the game. Encourage students also to share their different strategies to find the total number of dots, and ask them, how did you see it? And it can be varied by asking students to write the number and draw the pattern they saw, or by having them build the number flashed on their own blank 10 frame. Another variation is one more. So once your students are familiar with the basic pattern and they know those numbers automatically, flash up a 10 frame and ask, what is one more than the number flashed? And then you could also do one less or 2 more, double, and then I wish I had 10. You could flash a dot card or a 10 frame showing 9 and say, I wish I had 10, and then your students would respond with the part that is needed to make 10. And the game can focus on a single whole or a wish I had number that could change at each time. So like I said, this really isn't a game, but it's preparing for the next that is a game, for a variation of I wish I had 10. You would need 2 people. Partner A rolls a number cube and records that amount in the table on the game board. So underneath the roll, right here underneath the roll, they would record their amount in the table. Partner B then finds a 10 frame card that matches and places it on the game board. So then they would place it here on this game board. Partner A, or together, they could determine how many more they would need to make 10, and they would record that here on this spot. Then the partners switch roles. Partner B rolls a number cube and records that amount in the table on the game board. Partner A finds the 10 frame card that matches and places it on the game board. Partner B, or together, they can determine how many more to make 10 and record it here on the table, and continue playing until the table on the game board is full. You could also do a variation of this with make 20. And this is more akin to the rules for a game. This next one is called Shake and Spill. This is not my idea. This came from my Just Right number. If you've not visited that site, it's a blog from a teacher from Oklahoma, and I would encourage you to look at myjustrightnumber.com. So this is one of her activities. The students would have the red and white counters, and you would have some kind of a tray or box for them to shake the counters into the box. And the just right number in this case is 7. So they would shake them out and spill it, put the counters in the cup, shake the cup, then they would, when they spill them onto the tray, then they would line up the red counters and line up the white counters and then compare. They use their just right number, and then you want your students to know all of the combinations of a number without hesitation, and that's how you know that they have mastered that number. So then they would put these same counters in a cup again, shake it up, spill it out, and they then may have 5 red and 3 white. and you would want your students to record that. Then they would do it again, shake it up. This time they may have 1 red and 6 white, and then they would record that. This is a first step game that concentrates on recognizing the different parts of a number. Students begin to recognize the grouping of objects quickly, and that's what subatizing is all about. And these games also allow for differentiation as students are able to use the numbers 4 through 10 and beyond. myjustrightnumber.com. Connect 4. And I put up here an addition one, but you could also adapt this for multiplication. You would have your students roll 2 dice. They would add those 2 numbers together, and then they would cover their number with a marker, and the first player to get 4 in a row wins. So if I roll my 2 dice and I get an 8, when I add up the sum, I get a 5 and a 3, then I would cover up the 8. And then I would pass it off to the partner, and the winner is the one who gets 4 in a row. And like I said, you could adapt this to multiplication, division, subtraction, and just be careful on the division. This does involve a lot of strategies for where do I place my number. If I roll a 5 and a 3, do I want this 8? Do I want this 8? Do I want this 8? So there are some strategies involved in wanting to win the game. You may know about the Rekenrek. I am fairly new to this device, although it's not a new concept. The Rekenrek, or some people call it the arithmetic rack, is used to support the natural development of number sense in children. It consists of 10 rows of 10 beads. Each row is made of 5 red beads and 5 white beads. And this allows students to make mental images of numbers. So they're using 5 and 10 as anchors for counting, and adding and subtracting is more efficient than the one-by-one counting. The Rekenrek provides learners with a visual model. They need to discover number relationships and to develop addition and subtraction strategies, including the doubles plus 1 or the -1 making 10s, which leads to that automaticity of basic facts. So some of the activities that you could do with the Rekenrek is to just ask your students what they notice about the Rekenrek. This picture does not show it, but the start position, all beads would be to the far right. And have them practice sliding beads in groups rather than by one. So you could say, put your beads in the start position. Now, without touching the beads, count the first 3 beads in your mind. And then you would ask them to do that. And then they would slide 3 beads. Instead of sliding 1, 2, 3, they would know automatically to slide all 3 at the same time. You could also ask your students to show a number. So for example, you could say, show me 9. And instead of counting one by one, you would want them to count, to slide all at once. You could increase that from between 11 and 20. For example, you could ask your students to show you 13, and they would push a row of 10 and then push a row of 3. You would want them to do that only in 2 pushes. Okay, again, this one is not a game in the true sense of the definition, but you would need to do activities like this before asking your students to play this next game. Break it to 100. So partner A rolls a dot cube or a die and moves that many beads on the Rekenrek, starting at the top. And as they move the beads, they would say the number. And then after partner A has updated the Rekenrek, they count what is left to get to 100. But again, you wouldn't want your students to count one by one. They would count by rows of 10. Partner B then records that start, the amount of the roll, the end result, and what is left on the table provided. And then they would say those numbers out loud. Then it would be partner B's turn to roll the die or the number cube, adding on where partner A left off, and partner A then would be the recorder. And they repeat taking turns until they get to 100. You could also adapt this for rolling 2 dice or multiplying instead of adding the 2 dice together. Go fish. Kids love playing go fish. What about adapting it to 10's go fish? In this game, the object is to make combinations of 10 with 2 add-ins. So you could play in pairs, in groups of 3, in groups of 4. Each player is dealt 5 cards if you have more than 2 people, but if you only have 2 players, you could do 7 cards each. And the remaining cards are placed face down in what I call the pond. Players may not place any combinations of 10 already in their hand in the discard pile before it's their turn. So they have to take turns. The player to the dealer's left starts by asking a specific player for a card that will make 10 with a card that's already in their hand. So if this is my group of cards, then I could say, Kathy, do you have a 6? So that then it would match to make 10 with my 4. And if if Kathy has that card, then they have to give it to me. If I'm asking, or the asking player asks a specific player for a card and receives that card, then I put my combination of 10 in a discard pile, and I get another turn and ask someone else for a card to make a combination of 10. And if that player does not have my card, then he or she would say, go fish. And the asking player draws a card from the pond. If the card that I'm looking for is not drawn, then I add that card to my hand. And if by chance I would get the card I'm desiring, then I do get another turn. And then the play continues going clockwise. Play continues until someone has no cards left or the pond is empty. And if a player has no cards left, I could draw 5 new cards to keep the game going until the pond is empty. And then when the game is complete, you would want your students to list their combinations of 10 on a recording sheet. So are games really mathematical? The concepts that the few that I've shown you may not seem mathematical, but they really are. Playing games and the concepts related to them lay the foundation for future learning in mathematics. If a child learns to put objects in order from least to greatest, then they will be able to do the same for a set of numbers. A strong sense of numbers and how they are used will enable your students to understand place value. For example, that the number 256 consists of 2 groups of 100, 5 groups of 10, and 6 ones. Understanding place value is necessary in learning complex addition, subtraction, multiplication, and division problems. And understanding those part-whole relationships is necessary when learning fractions and decimals. And problem solving is a skill that is used throughout not only your students' whole school years, but throughout their entire life. If you haven't seen this publication, Building Conceptual Understanding and Fluency Through Games, I want to call your attention to that. It was created by teachers in North Carolina, and there are different sections for K through 5, and that's a great resource to use when you're looking at games. And also NCTM, Teaching Children Mathematics blog, Why Play Games, is a great resource. It has many games to use with the connected standards, and it looks like that. That's a link from NCTM, Teaching Children Mathematics blog, Why Play Math Games. So is it just enough to play a game and then we're done? Of course not. If children play a math game at school or at home without reflection afterwards, then the chances are that they've wasted an opportunity for learning. It's important that your students consider the mathematics involved in the game, the challenges that were faced, and the strategies that were included. Often we don't know if children learned anything when playing a game unless we ask some very strategic, reflective questions that they could either answer verbally or record. Some examples of some good reflection prompts could be: write a note to someone about the most important mathematics you learned while playing this game. Or ask them, what was the tricky part about the game? Or what strategies did you use to help you play this game? You could also ask your students, write 2 things that were difficult when you played the game. And can you connect the math that you used in this game to something you already know? And where would this knowledge be useful? Where could you use this information? You could ask your students, what were the fun pieces when you played the game? What was the most fun about the game? And how did you feel when you played with your group? You could also ask your students, what were their strengths when playing the game? And what would be some advice you would give someone if they were going to play the game in the future? And could you give me a suggestion for changing the game when we play it next time? And what would you do differently as a player of the game if you were to play the game again? And some other games that you could play with your students: Mancala, Monopoly, any kind of card game, Uno, Dominoes, concentration. There are lots of iPad apps out there that are based on mathematical games, and there are great games out there for mathematics teaching and learning. Just be sure that we, as teachers, connect those to the mathematics. And it's important that we encourage our students to engage in mathematics in a meaningful way and provide opportunities for them to reflect. So be sure to reflect. And this then it becomes more than just a game. It really is mathematical. I do see a question in the chat box. Is there a way to obtain the book as a parent? Yes. All of these resources are free on the NCT. There's a link on the NCTM website, nctm.org. In fact, that is right here in my references. Oh, I didn't put it there. I'm sorry. NCTM. Oh, right here. nctm.org, and you can get this information. Thank you very much for participating and for listening. And if you have questions, let me know. I'm at jkstramel@fhsu.edu. Thank you very much. I appreciate your time.